Unreal Engine 5.6 preview introduces the Instanced Actor Interop, which is experimental, but man, is it powerful. Now, Instanced Actors were introduced in 5.5, but there's just not been a lot of documentation for it, to say the least. But now that it's available with PCG, I've dived into it and tried using it, and let me tell you, it is extremely powerful combined with PCG. The short version of it is basically you spawn a PCG graph of all static meshes, and as your character moves towards one of these meshes that's been spawned, it swaps to a blueprint, and a blueprint that can have anything on it. And then when you leave that area, it goes back to just being an instant static mesh. So that means you can have things happen based on player location without very much effort to do any configurations and still have the performance, because most of the time the player is not next to every single instance, and so you get to make use of the instant static meshes and improve performance, which is great. But with that explanation out of the way, let me show you how it actually works, how to set it up, and a few cool ways you can use this for your games and other projects. Let's get into it. To get started, we're going to turn on the appropriate plugins by going to Edit Plugins, then search for PCG, and then turn on the Procedural Content Generation Framework, PCG, as well as the Instanced Actor Interop. This one right here, the experimental one, we want to have both of these on. And you want to search for Instanced Actors, and you want to turn on the Instanced Actors plugin as well. Make sure that is on. As you can see, it is also experimental. But once you have all the turned on, go ahead and restart your engine as needed. For this demonstrations, I'm going to be setting up a very basic setup where I'm going to have tables populated all around. And when I come up to them, we will spawn an object on top of it that will go away once we leave that area, because that object, once we get really close to simulate a pickup of the object, will then disappear. And when we leave and come back, even though it is regenerating that instance, it will still not have an object because we've picked up that version. This will create a scenario where you could potentially have a lot of tables where you can have a pickup here and there for your game, but the pickups don't get generated until the player is actually nearby. And if the player is far away from everything, they're all nicely instanced, increasing performance. You don't have to load up all the extra stuff unnecessarily, only when the player is there. So let's get started on that. We're going to get started with a PCG graph by just right-clicking, going to PCG and grabbing a PCG graph. And this is going to be our PCG table interactable. I'll go ahead and open it up. Now, if you've not touched 5.6 previously, and you don't know all the new PCG stuff, I recommend checking out my previous video. I go over all the new UI stuff with PCG. So on this one, we're going to make it very simple. I'm just going to right-click and create a simple points grid. The grid extents I'm going to set to 2000 by 2000, and the coordinate space I'm going to say as local component. Then I'll take our PCG graph, drag it into the world, and just put it at 0, 0, 0 for just convenience. So now that's in the world, I can press A on create points grid, and you can see there are points. We have a lot of them. They're very, very dense, and we don't need this much. So from here, let's do a simple select points node, and I'm going to keep something like 0.05. And then if I press A on select points, you can see we are left with far fewer. In fact, we can even go like 0.02 and just really go down in the amount of points in here. So all of these locations will be a simple table. So from here, I can drag out and then grab ourselves a spawn instanced actors. So right here, by default, it will give you an error. That's because we haven't plugged in our actor class. So let's go ahead and create a blueprint for it. Now right click, grab ourselves a blueprint class. It's going to be of a type actor. I'm going to call it BP underscore table interactable, and I'll open it up. This part will be nice and simple. We're just going to add a static mesh to it. I'll plug in our table here. This one will do just fine. And because I want to spawn something on top, I'm going to duplicate the static mesh, but I'm going to use it just for reference of the location. And the second static mesh, I'm going to swap it to this bull's head, and I'm going to move it up. So I want it to be around in this location. This is pretty good. This is going to be our pickup. But after that, I can go ahead and just clear it out. And I'll rename this in the outliner to be our pickup mesh and table, so I know what is what. Now we have this BP table interactable. In our spawns insert actors, I can go ahead and select it. There's our BP table interactable, and go ahead and select it. And immediately you will see a lot of warnings. BP underscore table interactable underscore C does not have a matching class or superclass entry in the actor class settings registry. Don't worry, we will take care of this in just a moment. For now though, we can already see in our world are all the tables. And in the outliner, if we take a look, you could see we have Instance Actors Manager. And if I turn off the Instance Actor Manager, you could see they all disappear. Instead of having each one of these as blueprints, they're separated. So now let's get rid of the warning. What we need to do is create a data registry. So if I right click and go to Miscellaneous and then Data Registry, go ahead and select Data Registry, click Select. I call it DR Table Interactables. And if I open it up, we will be met with this. It's going to ask for the registry type and a few other things. Now, how do you know what to put in here? Well, if you go to Edit, Project Settings, and then under Engine, Instanced Actors, right over here, you could select it, and you get the Instance Actors section. You have the grid size. This is basically, as it says, the 3D grid size distance along a side for partitioned instanced actor managers. So when you create a big area, how big of an area should it use for each section? In my case, I'm not using partitions, so I'm going to leave this alone. But then you see here's the named settings registry type is the instance actors named settings. And I want to make a note of this. This is what I want. So under item struct, I'm going to search for instanced actor. You can see there's instance actors class settings. I'll go ahead and select it. And I'll also type it into the registry name, instanced actors class settings. You want to make sure you type it in exactly. That's why I put it in here first, so I can have a full reference to make sure I don't misspell anything. And then we need at least one data source, so I'll go ahead and click plus. From here, I will use a data table for convenience. So we'll select data table source and open it up. And now we'll need a data table. I don't have a data table, so what I can do is click this data table button, and it'll ask me where do I want to create it. I'll create it in my folder. I'll call it DT Table Interactables and hit save. It's going to ask us to pick a row structure that a data table is based on, which maybe you could have guessed by now. It is also going to be instanced actor class settings. Go ahead and select it and hit OK. At this point, we can open up this data table. So you can see it is empty. It has the row name, override settings, and base settings. So all we need to do is hit add here. This will get us a new row with all the information. And now this row name. The row name needs to be this actor with the underscore C at the end. So I'm going to double click on row name, and now I'm going to rename it to BP underscore table interactable underscore C and press enter. If I just expand it a little bit so you can see it, there it is. So you want to make sure it is the exact name that it is asking for. And now down below, you have some settings here. You can see you can turn off your instances of casting shadows. You can have it control over physics. You can have it not affect navigations. You can see here, you can override all of this per actor. You can even override the full actor here if you wanted to. And we'll play around with some of these settings in a bit, but this is what we need here. But we're not quite done. From here, you need to go edit project settings one more time. You're going to want to go to data registry under game. And you want to add a directories to scan. So I'm going to hit plus here and then hit the 3 dots on index 0. And I'm going to tell it to scan the instanced actors directory, which is where I'm holding this data registry. Now this is very important. So now I'm good with the project settings. Now you will know if you did everything correct if you go back to your PCG graph and you just click force regen. If you click this button, Force Regen, and you regenerate your BCG graph and no warnings come up, congratulations, you did it correct. Honestly, that is the hardest part. Genuinely, that is the hardest part. So if I go ahead and hit play, you can see there's my characters, there's all of these guys, and one thing you might notice is in the outliner right now, you can see the tables just disappeared from the outliner. So these are actually updating in real time as I come near them. You can see in the outliner, potentially, the tables appearing and disappearing, but it's hard to tell at this point. So let's do some stuff to our actual actor here to make it properly work. So what I'm going to do is just add a sphere collision to our blueprint here. Now let's make it, let's say, yay big. That seems plenty. And now with that in there, I can right click on the sphere, add event, on component, begin overlap. I'm going to drag out of other actor and uncheck context sensitive. I'm going to type in player controlled. And I'm going to say for pawn is player controlled. I'm going to select it. And I just have a nice little check here that's just going to tell me if the player is the one that is overlapping this. So if this is true, I want to take the pickup mesh and then set the static mesh on it to the bullhead that I had. If I hit play, well, this one has the bullhead next to me, and then this one does. This one. And you can see they maintain having the bullhead, but if I go far away enough, they stop having it until, again, I come closer. Now, might be hard to understand what is going on, but we can fix that. There's also a possibility you're going to get errors from this instigator. That's because we just didn't change the sphere collisions here. So I'm going to go to collisions for the sphere. Instead of overlap all, I'm going to do custom. I'm going to tell it to ignore everything and then just overlap pawn. This way we just overlap basically the player, any other character, if that's all we want. And And the other thing I'm going to do is on this sphere collision, I'm going to search for hit it in game, and I'm going to turn that off and hit compile. So now I've hit play. You can see there's our spheres. You can see the ones further in the distance there don't have it until I get closer. So at this point, once you see the sphere, that means they're close enough to be actually a blueprint actor instead of an instant static mesh. So now we can see based on this distance, which we can actually adjust. We can adjust at what distance this happens. Inside of the data table, we can set the max actor distance. If I go to like, let's say 500 for the max actor distance, you can see there's our bull right next to me. And as soon as I go not very far away, it immediately turns off. In my case, I'll go ahead and reset it back to where it was. That is fine for this demonstration. So great, we now have the bullhead pop up, and it is only doing it on the ones nearby and only if we go and overlap it. But that means that the bullhead is there, and if we, let's say, came to pick it up, well, I want to disappear and not come back. This is not quite what I had in mind. So now, instead of on begin overlap, we spawning it, I'm going to do it on begin play. So on begin play, we're going to set that static mesh, and then on begin overlap, what I'm going to do is take our pickup mesh, and I'm just going to search for destroy component, and we want to destroy the pickup mesh here, and that is going to be untrue. So when we overlap it, we're actually going to destroy it, but it's possible we already destroyed it if we come into it again. So I'm going to convert it to validate get. Only destroy it if it is actually still there. Obviously, if it is not there, then don't. So now if I hit play, you will see every single one of these has the head on top, except this one, which I'm slightly overlapping. And when I come close to this into the hitbox, the bullhead disappears. But here's the thing. If I run away, they're no longer instance actors. They're just instant static meshes. And if I come back to them, when they load it, the bullhead is again back. Because this is a very important note. With instance actors, when they unload and they reload from scratch. It is a brand new actor. It is not remembering what that actor was between each version. So now if I want to, let's say, have the head not be there when I grabbed it again, we just need to have like a manager that retains the information of these points, and then we can have this actor check against those points and say, hey, did you already grab this? If yes, then we don't need to spawn it, and if no, then go ahead and spawn it. That might have been a little confusing, but don't worry, I'll guide you through it and explain along the way. So what we're going to do is we're going to right click and grab ourselves a new blueprint class of a type actor. I'm going to call it BP Interactable Table Manager. I'm going to open it up. We're going to need just a few things here, starting with a simple variable. This is going to store the locations of all of these points. We're going to call it locations. I'm going to change it to a vector and right click to make it an array. And then we're going to need two functions. So we'll go ahead and add a function. This is going to be for checking the location. So I'll call it check location. Here I'm going to grab the locations variable and I'm going to use a find item. I want to try to find what is being piped into it. So I'll just drag right into the input. It'll just populate the item to find. I'll just go ahead and select it though and rename item to find to location. Now this find node returns a -1 if not found. So we want to check if it was found. So we'll just go ahead and check if this was not equal to a -1. If it is not equal to -1, that means it has found something. That means we are good. So now I can just drag it out of check location, grab ourselves a simple return node and plug this output right into the return node. And I'm just going to rename the return value to found. Because if this is true, that means it has found it. And that's all we need for this one. But we need one more, and that is going to be our add to locations. Because we also need to add the location to it when it is a new location. Now in add locations, we grab our location variable as before, but this time we drag out of it and select add unique. Now unique is very important because you don't want to add a locations you've gone through already. So we'll go ahead and plug that in and plug again the vector right into the input and rename it to location. With that out of the way, I'll go ahead and just drag it out into the world somewhere so we have it there. So now how do we make use of this? Inside the blueprint where we house this table and pickup, I want to see if I should be spawning this static mesh at all. But we need to get a reference to this guy right over here. And there's many ways of doing this. I'm going to just take the simplest one for my demonstration because that is not the focus of it. And I'm just going to do a get actor of class in the world. So on begin play, I'll detach the set static mesh. I'm going to search for get actor of class, and I'm going to get the singular one. And I'm going to search for my actor, BP Interactable Table Manager, and there it is. And then I'm going to right click on it and promote it to a variable. And I'm just call it manager reference. That is good enough for me, just so we don't have to get it again later on if we ever need it. So now from here, I can go ahead and say check location. And the location that we are checking are its own. Get actor location, because that is the location of the actor that has now spawned. So now, based off of this, we can do a branch, and we could say, was this found? And if it was, that means it's been removed. We don't want to spawn it. So only on false, spawn the static mesh. So we'll only spawn it where it needs to, but we then also still need to remove it when we go ahead and get inside of that overlap sphere range. So now using the manager reference, I can just grab it from my variables. I can say add to locations, and just like above, I'll plug in get actor location into location. And now with the simple setup, let's take a look. As I hit play, you can see I'm overlapping this one already, so it no longer has the head. And if I move out of the way and then come back to it, it still does not have the head, but this one does and the others do. If I go ahead and run over the sphere, it goes away, it goes away. And if I go and unload them back to instance static meshes and reload them, it does not populate the head back. So if you had an interactable setup here, you could just keep track of which ones were picked up based on the location of the actor and then spawn or not spawn based on certain criteria, and you're good to go. Now, one thing you might notice is the head, right, is not spawned in here. And also, neither is the hitbox, right? The ones in the bag don't have the hitbox showing, even though on the actor, it is there. On instant actors, only the static mesh is live, because it is, in the end, effectively an instant static mesh that has been populated around. So that's why it's only supporting meshes. It will not spawn characters or decals or anything, but it will when it becomes an actor in range, which means you can do very interesting things with this. For example, I can add a simple point light. I can put it above here and compile it and just leave it as a simple dynamic light. And now when I hit play, the one right next to me has lights on, but the ones further out don't. Now, it's not a very strong light, so if I really increase this and then compile it, you could see as I run around, the lights turn on. Effectively, using this method, we have a sensor based on player location to turn things on and off automatically. Do you want to make a spooky hallway where as the player runs forward, lights turn on in front of him and behind him, the lights keep turning off as he runs further? There you go. It's automatically set up for you using this method. Because it is basically player distance based, anything that requires you to have anything set up through a distance of the player, you could automatically have this done. It will just swap to it and swap back. Now, there are some caveats with this swapping back. Things like moving the actor. Over here, I have a separate blueprint actor. This is just a static mesh set as the root, and I have turned on simulate physics for this one. Now, in this one, I also have an instance actors component, but as you saw from my demonstration with this, I didn't add it in. It seems like you don't need it. Everything still works, everything's still fine, and on this instant actors component, there aren't really any settings either. So my guess is you don't need it, but just know that it is there just in case in the future, maybe you find out some new information where for a certain thing, we do need it. So it is there for you. But effectively, this is just a physics cube. In this version, you can see this is not casting shadow until I come closer, but I can push them around. But watch what happens when I push them a little bit too far. Oh, where'd it go? It has returned to where it used to be. If I go ahead and push this one, it'll be the same thing. I cannot push this way too far because if I do, it will return back. Now, in our settings for this one, I have instances cast shadows turned off, which is why the instances don't cast shadows. But if I want to actually make it so I keep the physics object, we need to turn on eject on actor moved. Turn that on and enable it to the right. And then we can say the distance for this threshold. By default, it is 1. So if it moves at all, it will automatically eject. So if I'm going to set this, let's say, at 1,000, let's see what happens. Well, now I'll go ahead and play. And again, we have the same scenario. They go ahead and drop down when they become physics actors. But if I, of course, run away from them, they snap back up because it remembers the old location. If I move this a little bit and I run away, and again, it does the same thing. But if I was to move this over 1,000 units in distance away from where it was, well, it no longer spawns back. I can now run away from it as far as I want. That is now a regular actor in the world. It is now no longer part of this, let's call it hive mind. It is just its own actor that I can use as normal. Now, I've done a tutorial on setting up physics with PCG where it goes back and reattaches itself to the, let's call it hive mind of the rest of the graph. This won't do that, unfortunately. So in that regard, it might be better, depending on how many physics actors you have, to use the method I showed previously. I'll make sure to link it at the end of this video. But just keep in mind that you can actually move these and have them separated out if you wanted to, while keeping the rest, as you saw, completely instanced until you choose to move them. Now, you can't, unfortunately, just manually separate them out. Let's see, on Interact, you can't just say, hey, just remove it. It is purely when moved. But as you can see, with some of these settings, you still have a pretty good amount of control. You can even adjust the max instance distances. Now, I don't know why there are 4 actual options here, because it seems like only index 3 was actually doing anything. If I set this, let's say, to 500 from 10,000, and then I hit play, well, I only get the one right next to me, because the culling is now only showing me the ones, that are very close by, and until they're within 500 units, well, they just don't appear. That is what the max instance distances is. So I'll go ahead and reset it, but just know that if you wanted to have things kind of pop in at certain distances, you can set it up this way. So there's quite a few controls, and as you can see, there's a lot of potential to be used here with PCG, because you can spawn them, set it up how you want in the blueprint graph, and just combine it all. So I think using this combined with PCG to spawn things, you can get really interesting and cool designs. And hopefully some of the stuff I have shown you kind of got your brain thinking of ways to use this, because I know for actual gameplay mechanics, a lot of the stuff becomes a lot easier using this thanks to PCG and it combined, and it opens up, I think, a lot of new options for game mechanics using this. And I'd love to hear some of your ideas on how to best utilize this in the comments below. But as always, the project file for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the description will be down below as always. And as I mentioned before, if you want to use physics actors and have them become physics objects only when you come close and not when you move away, check out this video right over here. That's going to help you do just that.